Okay, today we're going to look at 11.6 or shifting graphs. And in intermediate algebra, we're going to just touch on the basics of them. But when you get up into college algebra, you will use these same methods for shifting all types of graphs. You can use them on linear, quadratics, cubes, absolute values, square roots, lots of different things. We're mainly going to look at quadratics and square roots in intermediate algebra, but the basic shifting and transforming them will work for any graph that you're looking at. And so I just went ahead and put the basic formula for a quadratic. You won't really have to know this in intermediate. We're going to just look at two parts of it, but just so you'll have it in the future, that any number sitting in front of the parentheses is going to determine how tall it is. But all we're going to look at is that if it is a negative, it's going to flip the graph. So a negative sitting in front of the parentheses or the variable is going to flip the graph. The number inside the variable or inside the parentheses is going to move it left or right, the opposite, and I'll explain that in a minute. And then any number that's sitting outside of the actual variable is going to move it up or down the graph. Now, I did on your worksheet when you print it out, you do have a printout of all the different types of graphs that you have. A constant function, we talked about these back in 0300. This is the function x equals 2, horizontal line. Remember we talked about this is slope 0 and y would be undefined. A linear equation, again, we talked about this in 0300. This same thing works for it, shifting it up and down. What we're going to work with today, though, is the quadratic function and the square root function. But when you get up into college algebra, you probably have to deal with all of them. This is the y equals x to the third function. This is the y equals the absolute value of x function. This is the y equals the square root of x function, again, the square root. And this is y equals x squared function. But today we're going to concentrate on x squared and the square root of x. So remember when I talked about this, I think I talked about it back in 0300, that you graph by how many times the exponent tells you how many times the graph is going to change. This is actually the formula y equals x, or y equals mx plus b. Just the m happens to be 1 and the b happens to be 0. But you see that that's x to the first power. The direction of the graph just has one direction. Something to the second power has two directions. Do you see it goes down and then it goes up? Something to the third power has three directions, 1, 2, 3. And so you'll use that a lot up in college algebra also to think about what the graph's going to look like. Like something to the fifth power is going to change directions 5 times, and so it'll have lots of different turns and changes. But when we look at y equals x squared, it's always going to look like a u. It's called a parabola, but it always is going to look like a u. And so you do need to memorize what that looks like. So for y equals x squared, it's going to look like a u. So when we go to graph all these different versions of x squared, do you see we have x squared, negative x squared plus 2, x squared minus 2, and so on. These are all versions of that original graph, which is a u through x squared. Through 0, 0. I'm sorry. Y equals x squared is going to go through. Now, when you get up into college algebra, you'll graph these more with more points and stuff. But I'm just wanting you in this class to think about the basic look of the function and how it's going to move. So this is what they call a parent graph. This is what it originally always looks like. And now we're going to shift it and move it around. So let's look at this one. Y equals negative x squared. Well, what a negative does is just flip the graph. So instead of pointing up, it's going to point down. So it would look like that. Again, we're not being particular on the exact graphing. We're just shifting and making a general version of the graph. In college algebra, you will probably have to do a more precise method. So a negative flips it. So let's just write that. A negative flips. But now this one we have the x squared plus 2. So do you see that this plus 2 is outside the function? So it's like up here in the formula that if it's outside, it's going to go up or down. So outside is going to go up if it's positive, down if it's negative. So since this is a positive 2, it's going to go up 2, but it keeps the same general form of the graph. So I'm just going to go up to 2 and then draw my parabola, or my x squared. So outside is going to go up or down. So since that plus 2 is outside, it's going to go up 2. But you see this is a negative 2 outside, so this one's going to go down 2. So I'm going to go down 2 and draw the parabola. And you can make it go past the things too. So this plus 2 and this minus 2 are outside of that squared quadratic function. But I want you to look at these two. It still says plus 2 or minus 2, but these are inside the parentheses. And so when it's inside, and again, you can look up here at the formula, when it's inside the parentheses, it goes left or right, the opposite. So what I mean by that is, again, it's inside and it's a positive 2. So we normally think right is to the positive and left is the negative, but we're going to do the opposite of this. So since it's a positive 2, instead of going to the right, we're going to do the opposite and go left 2. And so we start on our graph, we're going to go to left 2 and draw our origin and then draw our view. Again, these are just sketches. They're not true graphs. You could always do an XY chart and do the full graph. This one though is a minus 2. So a minus 2 tells us you think you're going to go left. So I always say left or right, the opposite, because negative 2 is to the left. So you're going to do the opposite and go right 2. So I'm going to go to the right 2 and draw a point and then draw my parabola. So this is one way to think about it, left or right, the opposite. But the reason that is what would make the 0 would be a negative 2. Because negative 2 plus 2 is 0. So you're also thinking about what is the 0 of that parentheses. So if you have another professor and they talk about it that way, the 0 here would be negative 2. So we go to negative 2 and draw our parabola. The 0 here would be positive 2. So we go positive 2 and draw a parabola. So whichever way you like to think about it is fine. And so those are all the different shifts for a quadratic function or for something of the form x squared. Negative flips it. Outside, up or down, inside, left or right, the opposite. Okay, now let's look at the square root of x. Again, we've got our main functions here. This is what the square root of x looks like, because you can't have the square root of a negative. There's never going to be anything over here. And so you're really looking at those perfect square roots, and the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. It's always going to gradually increase as it goes to the right. And so it starts at 0 and then it's just kind of like a half parabola, or however you want to think of it. It's just a gentle curve to the right. It can never be over here positive. And one way I used to memorize what this looks like is think about the square root looks like this and the graph kind of looks like that. They kind of look similar. So think of square root as being that half curve starting at 0 and moving to the right. You'll probably have to memorize all of these when you get into college algebra. But again, today we're just looking at quadratic and the square root of x. Okay, so when you've got them all set up here, you want to look at this plus 2 is outside of the square root. These are kind of confusing, so you got to really pay attention to the line. This one's inside, this one's outside. So outside means go up 2 and then draw your square root. This one's outside, so that means down 2 and draw your square root. This one is inside. See how it's underneath the little house? It's inside. So that means left or right, the opposite. So if it's a negative 2, you're going to go to the right 2 and draw your square root symbol. Or remember, what would make that 0 would be a positive 2. I don't know why I jumped to 3 here, but we'll just do that. And then this one's inside. So we're going to go left or right, the opposite. That's a positive 3. So we're going to go left to negative 3 and draw the parabola. Okay. And then the last part, let's put them all together like we did in this first form here. I didn't do any of the numbers out. This gets a little bit more complicated when you have a number out front, and you'll do that in college algebra. But just remember, in parentheses is left or right the opposite. The outside part is up or down. So when you look at this problem, it looks really complicated, but you're just thinking, okay, this positive 3 is outside, so that tells me to go up 3. This negative 2 is inside, so that tells me to go the opposite of negative 2, which is to the right 2. And then this tells me it's a parabola. Since it's a squared, it tells me it's going to look like a U. So you just start at 0, and I'm going to go to the right 2, and then up 3. So to the right 2, up 3, and that's where I'm going to start my origin and draw my parabola. It's just like you put these two steps together. So combined all together, you just do what both of them says. And then this last one, the same thing. This is outside, it's a negative, so that tells me to go down 2. This is inside, so it's left or right the opposite. Since it's a positive 1, it's going to be left 1. And so on my little graph here, I'm going to go to the left 1 and then down 2, draw my point. But then I have to look back. This function is a square root here, so it's going to be the square root function from that origin. So again, these are rough sketches. That's all we have to do in this class. When you get up to college algebra, though, you'll probably have to have exact graphs, but your professor will explain to you what you need to do. Okay, so you're now ready to work the worksheet. Download it and give those a try.